Hello and welcome. Obviously, I am not here today, so I'm going to be taking you through the notes. This should be on the next page. Looks like, what is a matrix? Okay, so a matrix is an array of numbers arranged in rows and columns. The dimensions of a matrix is the number of rows, x the number of columns. Pretty simple. For example, we would call this one 3 rows and 4 columns. Or this one, 3 rows and 1 column. Or 3 rows and 2 columns. Now, when we're looking at a matrix, each number is called an element. And elements are written in the form of A, I, J, where I is the row number and J is the column. So if, for example, I say AI2, what that's asking for is row 1, column 2. So the value there would be 3. So A12 equals 3. Important things to note about matrices is to add or subtract, they must have the same dimensions. And if they add or subtract, when you're doing that, you add or subtract each corresponding element. So let's look at the first example for that. A plus B. Now, I think it's going to be useful for us here if I write it out. I'll do A, 4, 9, 6, -8, 2, 7. And then I'll write B just in a different color. -4, -3, 2, 5, 6, 3. Now, when I add them together, I'm simply going to add each part. For example, I'm saying 4 plus -4. That's going to be 0. Or then 9 plus -3. That's going to be 6. 6 plus 2. That'll give me 8. I go to the bottom. -8 plus 5. That will give me -3. And then 2 plus 6 will give me 8. And lastly, 3 plus 7 will give me 10. And I've added A plus B. Another thing we can do with our matrix is multiply by a scalar. When I'm multiplying, each element is then multiplied. So let's take a look at this. If I say 3 times B, so -4, -3, 2, 5, 6, 3, minus, again, I'll do A in another color just to denote the difference. 4, 9, 6, -8, 2, 7. I'm going to first multiply out. So 3 times -4 becomes -12, right? -9, 6, 15, 18, 9. And again, I'm just multiplying each piece by 3. I'm going to copy down again the A values. 4, 9, 6, -8, 2, and 7. And now I'm simply just going to subtract. So -12 minus 4. right? That becomes negative 16. Or negative 9 minus 9. That becomes negative 18. 6 minus 6 becomes 0. 15 minus negative 8 becomes 23. 18 minus 2 becomes 16. And 9 minus 7 becomes 2. And I'm done. I think at this point, you guys should go ahead and try to do 4b. And try to do D. A plus C. And I would pause at this moment. Okay, welcome back. We're going to look at one other part of the example. In looking at an example, we're going to try to solve for the variables of C and D. So let's start with C. I noticed that C, the element, lines up with 7 element here. So I'm going to say 7 plus 4 times C. That 4 is right here. It would be multiplied by C equals, and I look at the same element here, 23. Pretty exciting. And I just solve for C by doing inverse operations, right? And I'm left with C being equal to 4. Next, I'm going to go for solving for D. I look where it is in relation to the element, so I say negative 5 plus 4D equals, I look again here, negative 41. I, of course, move my parts over. I'm adding my 5. 4D equals negative 36. I divide by 4, and my D is negative 9. All right. Thank you for watching. Oh, wait. Pause for just a second. I do want to come back to this part right here. So, earlier, we had said they had to be exactly the same dimensions. Well, let's look at A. A is comprised of a 3 by 2. And C is comprised, A is comprised of a 2 by 3, right? You can see A is comprised of a 2 by 3, and C is comprised of a 3 by 2. So these dimensions aren't the same. There's no way we could add them. And therefore, we just say this does not exist. It's like saying it's not possible. We also call that D in E. All right, perfect. Thank you.